Okay, welcome back everyone. This is okay. So these two are actually some very nice questions. I want you to try them first and then actually see the solution. So for the first question, they have even given us a hint that do not actually solve the equations. Okay, so I hope that you have tried these questions by now. So now I'm going to present what I did. Okay, so for the first question, we have to find sum of all the real roots of this equation. So we do not need to find the roots themselves, but their sum as okay. So we want to find the sum in fact. So here's the thing. This equation is cube root of 6x plus 28 minus the cube root of 6x minus 28, which can be written as plus the cube root of 28 minus 6x is equal to 1. Okay, so here's the thing. I'm going to substitute minus x as u, right? That will give me that this equation will be transformed to the cube root of 28 minus 6u plus the cube root of 28 plus 6u equals to 1. And the good thing about this thing is that yeah, this equation and this equation, these two equations are actually the same thing. So what that means is that if I substitute x as negative u, whatever values of x I get from this equation, the same values of u I will get from this equation. Okay, so suppose you got uh, some root of this equation as alpha. So you have x equals to alpha. That will give me u equals to negative alpha. But you will also have that as a root of this equation because these two equations are actually identical, which means that you also have u equals to alpha or x equals to negative alpha as a root. So if you have x equals to alpha as a root of this equation, you also have x equals to negative alpha as a root of that equation, which pretty much means that the sum of the roots has to be 0, right? And what about the number 0, which does not have an additive inverse? Well, it's just 0 itself, so no problem. Which means that yes, the sum of the solutions of this equation, it has to be 0 because of the symmetry. And I think it's called something, it's called uh turn symmetry, something, I don't know. So whatever the kind of symmetry that is, because of that thing, the sum of the solutions is turning out to be 0. And yeah, that's very nice. Let's go to the next question. So the next question says, for what m belonging to real numbers, the expression 2x squared, let's write this down so that you can see that as well. 2x squared plus mxy plus 3y squared minus 5y minus 2 can be factorized uh, into these two things. I mean, like, can be factorized into two linear factors basically. Also, for those of m, factorize the expression. Okay, so here's the thing. If this expression can actually factorized into two linear factors, that means that for every value of x, you will have at least one value of y, which means that for any value of x, this equation is supposed to have some value of y which will satisfy it, which means that for any value of x, the discriminant of this equation is greater than or equal to 0. So yeah, that's a nice thing. I mean, the discriminant in, if you view this as a quadratic in y, all right, so that gives me 3y squared plus y into mx minus 5 plus, yeah, plus 2x squared minus 2, right? This expression has a discriminant greater than or equal to 0. So you will have m squared x squared. I mean, this is actually true for all real values of x. So that's nice. So like m squared x squared minus minus 10x, I mean like minus 10 mx actually, plus 25 minus minus 12 into 2, supposed to be minus 24 x squared, and then plus 24. Yeah, that's supposed to be equal to greater than or equal to 0 for all x belonging to real numbers, right? So what can we do with that? Gives me m squared minus 24 into x squared minus 10mx. Yeah, that looks correct. Minus 10m into x. Got plus 25 plus 24. Yeah, I think it's going correct. It's supposed to be equal to 49. is greater than or equal to 0 for all x belonging to real, which means that the discriminant for this quadratic has to be less than 0 and the coefficient of x squared has to be positive. So you have m squared is greater than or equal to, I mean, not equal to, it has to be strictly greater than 24. Um, yeah, and we also want to factorize the expression. So that's fine. M is greater than 24. Should it be greater than or equal to 24? Well, no, 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 not like that. So it does not need to be greater than or equal to 24. And you want the discriminant. Okay. So m squared is greater than or equal greater than 24. You want the discriminant to be less than 0. So you want 100 m squared minus 4 into that stuff. Okay. So minus 4 into 49 is 1636, like 196. Okay, it's like minus 196 m squared. Oh wow, that's okay, that's not nice. What about just factor out a 2 from that? So like 25 m squared minus 4 gets cancelled, so it's got 49 m squared plus 24 into 49. Yeah, that's supposed to be equal to, okay, not equal to, less than or equal to, actually not even less than or equal to, just less than 0. No problem. So what's this thing supposed to be? You got 24 m squared, right? Minus 24 m squared plus 24 into 49 is less than 0. So yeah, you will have m squared is greater than 49. So that's nice. And similarly, we also had like m squared is greater than 24. Fine. So this is the, yeah, this is the better one. The, yeah, it's like the better solution stuff. So m squared has to be greater than 49. Okay, what else? um the expression 2x squared plus mx plus, did we make some kind of mistake somewhere? So we did take t greater than or equal to 0 for all x belonging to real numbers. So you got b squared, which is, wait, where is it? Okay, mx minus 5 squared, I think. Yeah, mx minus 5 squared, no problem. Okay, so that squared is like m squared x squared minus 10 mx plus 25. Yeah, that's correct. Minus 4ac, so like minus 4 into 3 is 12 into 2 is 24. So minus 24x squared plus 24. That's also correct. Has to be greater than or equal to 0 for all x. Yeah, that's fine. What? How do we solve this thing? Also for those of m, factorize the expression. How do we solve that thing? Yeah, that we do not know how to solve. We want to factorize the expression. Okay, well, we did find a discriminant somehow. So yeah, m squared x squared. Okay, that's fine, just move on. So we'll have m squared minus 24 into x squared, yeah, minus 10 mx. Okay, plus 49. That looks correct. Greater than or equal to 0 for all x, and that means that discriminant has to be less than 0, and this has to be greater than 0. So like m squared is greater than 24. That's correct. And then you got b squared, but take out the 2 from that. So like 5 squared is 25 minus 4ac, so minus 4 is gone. Just have minus of ac, which is minus 49 m squared plus 24 into 49 has to be less than 0. So yeah, that makes sense. You just got minus 24 over there. So m squared has to be greater than 49. Yes, like that's fine. Also for those of m, how can we do that? How can we factorize the expression as well? So 2x squared plus mx plus 3y squared minus 5y minus 2, how can that be factorized? um yeah, sure, you can actually use the quadratic formula on that thing. I mean, on this thing you can use the quadratic formula, but is that actually is it actually nice to do? I mean, will that give me any nice solutions? I don't think so. But yes, it can be used. So you can actually use the quadratic formula to find the values of y in terms of m and x, and then from that thing you can yes, you can find the linear factors, right? The equation for that line. That will be it. That will be how you solve that. So yeah, that's fine. That is supposed to be the factor. So yeah, we can actually factorize this, but but with a radical, basically, with a quadratic term in x and a radical on top. I'm not sure if this is called factors, but yeah, that's how it's supposed to be factorized. So hope you enjoyed this video.